Welcome. In this video, I will talk about the process of finding the gradient of a scalar field and directional derivatives concept. So let's start. First of all, let us be clear that what I am going to discuss here. So in this video, I will be discussing about how to evaluate the gradient. Second, geometrical meaning of gradient and its related concepts and problems. And I will also discuss directional derivative and its related concept and problems. In case if you are new to the channel, you should subscribe because here you get good quality video content. So let's start. So first of all, let's be clear about the definition of gradient of a function. So let f of xyz be a real valued function defining a scalar field. So first of all, you need to understand that when I talk about gradient of a function, I take the scalar field. So here I am taking f of xyz to be a real valued function which defines a scalar field. The gradient of a scalar field that is given by f is denoted by del f. So either I use this notation or I use this notation. And how it is defined? It is defined as I del by del x of f plus j del by del y of f plus k del by del f of del by del z of f. So here I, j and k, I hope you know that I, j and k are unit vectors in the direction of x-axis. I is the unit vector in the direction of x-axis. J is the unit vector in the direction of y-axis, and k is the unit vector in the direction of z-axis, right? And I hope you are also clear that when I talk about this del operator, basically this del is defined as the operator which I can write as I del by del x plus j del by del y plus k del by del z, right? So if I operate this on the function, so this is what I am saying, that suppose the function is f, and on this if I operate f, what it will become? It will become like I del by del x plus j del by del y plus k del by del z, and on this I am operating f. So if I operate f on this, I will get what? I will get I, and del by del x of f will become del f by del x plus j del by del y of f will be del f by del y and plus k del f by del z. So this is what I have written here. So this is the way we calculate the gradient of a scalar field. I hope you are clear about one very important point here, that gradient of a scalar field is a vector quantity. Gradient of a scalar field is a vector quantity. We take a scalar field, so this is a scalar function, but if I calculate its gradient, what I get is a vector quantity. So sometime they also ask this, that can we calculate the gradient of a scalar field? The answer is yes, and what I will get? I will get a vector quantity. So to understand it, let us solve a few problems. So the first problem that I am going to solve, that find the gradient of the following scalar field. So there are two parts here, so let us solve the first one. So here the function is given in two dimensions, like we have just y and x. So how do I find? I find a gradient of del of x comma y. Del of means f of x comma y. So how should I find? First of all, what will be the del operator in this case? Del operator in this case will be I del by del x plus j del by del y. There is no z component, so I will just take I del by del x plus j del by del y, and I will operate this on the function that is y square minus 4xy. So if I evaluate this, what will I get? I and del by del x of this expression. So partial derivative of y square with x will give me 0. The first term will give me 0. And if I differentiate minus 4xy, I will get minus 4y, right? And then I will take j, and if I differentiate it partially with respect to y, del by del y of y square will give me 2y, and minus del by del y of 4xy. So this will give me what? 4x, because 4x will be a constant. Del y by del y is equal to 1. So this is the value that we are getting, which I can rewrite that minus 4yi plus 2y minus 4xj. So this is the gradient of this function, but we have to evaluate the gradient at a point. So at the point 1 comma 2, what will be the gradient? So the gradient at the point 1 comma 2 is equal to, I put the value of y is equal to 2, so I will get minus 4 into 2 is minus 8i, and plus here if I put the value of y is equal to 2, I will get 4, and if I put x is equal to 1, also I will get 4. So 4 minus 4j, so this quantity will become 0, so I just get the gradient value, that is minus 8i. So here the direction of gradient is in the negative direction of x-axis, that is minus 8i. I will also talk about what is the meaning of gradient, right? So some of you might be thinking that I am just calculating, I didn't talk about the meaning of it. I will talk about it, but before that, let us talk about the solution of this problem, right? So here I am moving to the next page, and I am talking about the second problem. So again, here the second problem has three variable x, y, z. So if I have to calculate the gradient of f of x, y, z, then I will be taking what? I will be taking the del operator as I, del by del x, plus j, which is the unit vector, del by del y, plus k, and then del by del z. And what is the function here? The function that we have is x square y square, and then plus x y square and minus z square. I hope you have noted it. The function is x square y square plus x y square minus z square, and we have to evaluate at 3 1 1. So first evaluate it. So how do I evaluate? We have to take the partial derivative of this expression with respect to x. So x square y square will give me 2xy square. X y square will give me y square, and there is no x term, so this will give me 0. So I close this bracket. Then I take j cap, and del by del y of this will give me what? It will give me 2x square y. Del by del y of xy square will give me 2xy, and there is no y term, so this will give me 0. And then I take k. So here we note that there is no z term in the first term and second term, so I will just get minus 2z if I differentiate z square. Okay, so we have to calculate at point 3 comma 1 comma 1. So 3 comma 1 comma 1. If I call this vector as vector b, so gradient vector b, let me call it b vector. So v vector will be what? I have to put the values of x is equal to 3, y is equal to 1, and z is equal to 1. So I will get what? 2 times x is equal to 3 and y square, that is 1 square, and plus 1 square I, then plus if I take this term 2 times 3 square into 1 plus 2 into 3 into 1 j cap, and then plus minus 2 times 1 into k cap. So if I simplify this, I will get what? 2 into 3 6, and 6 plus 1, that is 7. So I will get 7 I cap. If you look at this, 3 into 3 9 into 2 18, and 18 plus 6, so 18 plus 6 is 24, so I will get 24j, and here I talk about this, so I will get minus 2k, right? So this is what we have got. So the gradient of this scalar function at the point 3 comma 1 comma 1 is given by this vector. So we have understood the process of evaluation of gradient, how the gradient is evaluated. Okay, now moving ahead, let us understand the geometrical meaning of gradient. So actually what does this represent? So suppose if I am talking about a surface which is given by like the function, and the gradient actually gives us the direction of the normal vector to the surface. So suppose this is the surface, and on this, suppose I draw a tangent plane, something like that. Let me draw a tangent plane, and on this tangent plane the normal vector, so the direction of normal vector, so this is a normal vector to the surface. So the meaning of gradient is that it gives you the normal vector to the surface at the point at which you are calculating. So to understand it, let us quickly solve this problem. In the problem they are asking that find a unit normal vector to the surface, and I know that gradient can help us to get the normal vector to the surface. So before I do anything, I calculate the gradient. So I have to calculate del of f, and here we have three variable x, y, z. So I take I del by del x plus j del by del y and plus k del by del z. And the function that we have is that it can be written as xy square plus 2yz minus 8. So I write xy square plus 2yz minus 8. Now let us evaluate it quickly. So I cap as such del by del x of this quantity. So we have x in the first term, we have y square, so I write y square. There is no x, so I just close the bracket. Then we take the j cap del by del y of this, so y square will give me 2y, so the first term will become 2xy, second term will give me 2z because it is 2yz, and there is no y in the third term, so that's it. And if I differentiate the expression with respect to z, I will get k cap here, and with respect to z I will get 2y. So this is what we have got. But we have to calculate the unit normal vector at point it 3, minus 2 and 1. So if I calculate the gradient of the function at point 3, that is minus 2 and 1, what I will get? So I write directly, in place of y we have to put minus 2, so it will become 4i, minus 2 square is 4. And if I talk about 2xy, so 2 into 3 6, 6 into 2, that is minus 12, so I will get minus 12 and plus 2z, so plus 2, so I will basically get minus 10 j cap. And here 2y, so y is minus 2, so here I will get minus 4 k cap. So this is the normal vector. If I call this n vector, so this is the normal vector to the surface which is given by this expression. But in the question they are asking me to find the unit normal vector. So if this is the normal vector, how do I find the unit normal vector? You remember the vector and you have to divide it by the magnitude of the vector. So the vector here is 4i cap minus 10j cap and minus 4k cap, and if I divide it by the magnitude, what is the magnitude here? 4 square, that is 16. I hope you remember how to find the magnitude. So the coefficient of I, that is 4 square, then minus 10 square, that will be 100, and then minus 4 square, that is 16. Okay, so this is 132, and if you take the square root of 132, you will get what? You can consider it 4 times 33. Is it correct? 30 into 4 is 120. Yeah, so basically it will be 2 under root 33. So the value of this will be I will write it like 4i minus 10j minus 4k cap divided by 2 by under root 33. If you want to simplify it further, you can do one more thing. You can take 2 common and cancel it. So let me write it. It will be 2i cap minus 5j cap and minus 2k cap, and 2 has been cancelled, so in the denominator I will get under root 33. So this is the normal vector. One a small mistake I made here. If I am writing unit normal vector, I should not write n like this. I should write n cap, because this is the notation for unit normal vector. So I hope you have understood. If someone will ask you that a question that find the normal vector to the given surface, then how to find? You just have to calculate the gradient at that point. Okay. So using this concept, let us solve some more problem which is based on the concept of gradient and the normal vector. So here is a problem that find the normal vector and the equation of the tangent plane. So it requires some understanding of three-dimensional geometry. It is an application of the concept. So what is the problem? Find the normal vector and the equation of the tangent plane to the surface at the point this. So do you know what is the equation of the tangent plane? I first explain you that suppose we have to find the equation of a plane. First of all, learn the concept which is needed to solve this problem. So what is the equation of a plane? Equation of a plane. So equation of a plane is given by a into x minus x naught plus b into y minus y naught plus c into z minus z naught is equal to 0. Now you will ask me that what is A, what is B, and what is C. So A, B, C actually are the direction cosine, direction ratios or cosine. So here we are writing direction cosines of what? Of the normal to the surface, to the plane, because I'm writing the equation of the plane. For example, if you are watching this video on the screen and if you want to find the equation of the screen, right? Suppose for example I have a plane like this, right? So on plane I can draw a normal, right? So this normal will have some direction cosine. I don't know whether you know what is the meaning of direction cosine. So if you don't know, let me quickly explain it. So if you talk about this line will make some angle with x-axis, some angle with y-axis, and some angle with z-axis. So the direction cosine of a line is actually suppose this is making alpha angle with x-axis, beta angle with y-axis, and gamma angle with z-axis. So the direction cosine of this line will be given by cos alpha, cos beta, and cos gamma. So this is actually taught in the earlier classes. So I hope you do have some understanding. In case if you don't have, still you can solve this problem because I already have explained you the main concept. Now come back to the problem. So they are asking us to find the normal vector and the equation of the tangent plane to the surface. Now there is a surface here, and on that surface I have to find a tangent plane. So if I find the normal to the surface, that normal will also be normal to the tangent plane. Did you understand this? Suppose you have a plane, and on that plane you have drawn a tangent. You have drawn a tangent plane. So on the tangent plane, if you draw the normal, so that will be actually the normal to the surface also. So the first thing that I am going to do, I am going to find the normal to the surface. And how can we find the normal to the surface? By using the concept of gradient, del f. So I calculate I del by del x plus j del by del y plus k del by del z, and the surface that we have got, I can write it like z minus under root x square plus y square. Okay, so let us evaluate it. It is very easy to evaluate. So del by del x of this will give me what? Minus is there, and a square root will give me 2 under root x square plus y square, and 2x will also be there, 2x I cap. With respect to y, I will get minus 1 by 2 under root x square plus y square into 2y and j cap, and then I will get del by del z, so that will give me k cap, just because it will become 1. So this 2 and 2 will cancel. I will get minus x by under root x square plus y square I cap minus y by under root x square plus y square j cap and plus k cap. Okay, but we have to find the normal vector and equation of the tangent plane to the surface at the point. So we have to substitute this point in this. So I am moving to the next page, and I think we can at least write some portion over here, so that we don't have to change the page again and again. So let me write some portion of here. So if I ask you what is the normal vector to the surface at this point, so here x value is -3, and if I take under root x square plus y square, so 3 square plus 4 square is actually what, 25, which is square root is 5, so I will get -3 by 5 I cap, I will get -4 by 5 j cap, and then I will get k cap. So this is the normal vector to the surface at the given point. Okay, now the next thing is I have to find the equation of tangent plane. So if you look at this normal vector, this is basically the unit normal vector. I can change it to the unit normal vector, or even this when I am talking about this thing ABC, listen very carefully, ABC, either this is direction cosine or direction ratio, does not matter. So there is no need to change it to the unit normal vector. I can directly take -3 by 5 as the A value, -4 by 5 as the V value, and C value will be taken as 1. So what is the equation of the plane? So let me write the equation of the tangent plane is equal to what? We have got A value, so A value was -3 by 5, and x minus x naught, so x minus, and we have to find the tangent plane at point 3 comma 4 comma 5, so I will write x minus 3, then the coefficient that is b will be -4 by 5, and y minus y naught. So what is y naught? Y naught here is 4, and z will be 5, so it will be 4, and then z, the coefficient of this is 1. Coefficient of k cap is 1, so I take 1 times, and z minus 5, that is equal to 0. So this is what we get. If you want to simplify, you can simplify. You will get -3x, and minus minus plus, so plus 9. You will get -4y plus 16, and 5 will be multiplied there in the right hand side, this side, sorry. So I will get 5z and -25, and this 5 in right hand side will become 0. So basically what I got -3x minus 4y plus 5z. So -3x minus 4y plus 5z, and here we have 9 and 16 and -25, that will cancel. So which can be written as 3x plus 4y minus 5z is equal to 0. So this is the plane, this is the equation of the tangent plane. I hope you have understood the problem. Let me quickly summarize it, what I have done. To find the equation of any plane in 3 dimension, this is the formula, or this is the expression for the equation of the plane, and where x naught comma y naught comma z naught is the point in the plane. So suppose we have to find the equation of a plane, and we know that there is a point in the plane. This is a point in the plane, so that point is given by x naught, y naught, and z naught. And if you drop a perpendicular or normal to the plane, so that will give us the direction cosine or direction ratio. So A, B, C are either direction cosine or direction ratio. I hope you understand the difference between them. So actually, if I take cos alpha, cos beta, and cos gamma, these are the direction ratios. These are the direction cosine, or this ratio. If I take like 2 times cos alpha, 2 times cos beta, 2 times cos gamma, so that will not make any difference, because if you take the ratio here in the right hand side, it is 0, so that ratio can be taken common and divided in the right hand side. So ABC, for making it more general, are the direction ratios of the normal to the plane. Okay, think about it and let me know in case if you have any doubt. Let us move to the next problem. So the next problem is that find the angle between the surfaces x log z is equal to y square minus 1 and x square y is equal to 2 minus z at point 1 comma 1 comma 1. Now you need to understand that how do you find the angle between two surfaces. So if I have to find the angle between two surfaces, I can find the angle between the tangent to the surfaces, and that can also be kind of understood. So if I have to find the angle between the tangent, that will be equal to the angle between the normal to the surfaces. Do you understand it? Suppose I ask you that find the angle between this line and this line, right? Now to find the angle between this line and this line, what you can consider, you can take the normal to this line and you can take the normal to this line. So the angle between the normal is also the angle between the line, original line, right? Yes or no? Why we are thinking in that direction? That we know that it is easy to find the normal to the surface using the gradient. Are you getting my point? So let me solve it. So first of all, we have two surfaces. Let me call it f1 xyz. This I will represent by x log z minus y square plus 1 is equal to 0, right? And next surface is f2 xyz. So this I can represent as x square y minus or plus z minus 2 is equal to 0, right? So these are the two surfaces. So first I find gradient of the first surface, that is del of f1, and this time I am writing directly without using the the notation I del by del x. I am writing directly. So I have to differentiate this partially with respect to x. So I will get log z only and then I cap. If I have to differentiate this with respect to y, I will get minus 2y j cap. With respect to z, I will not get anything. Sorry, I will get one thing. Log z is there, so I will get plus x by z and k cap. Okay, but at point 111, what it will be, ladies and gentlemen, at point 111, let me call it normal vector 1 to the first surface. So if I take z is equal to 1, log 1 becomes 0, so that component will vanish. If I take y is equal to 1, I will get minus 2 j cap, and if I take x and z 1, so I will get 1 by 1 1, so that is k cap, right? So we have got the first normal vector. Now I calculate the del f2. So del f2 will be what? I have to differentiate this partially with respect to x. There is one term here, so I will get 2x y and I cap. Then with respect to y, I will get x square j cap, and with respect to z, I will get k cap. I hope you are getting it. Now we have to calculate at point 1 comma 1 comma 1. So let me call del f2 as the normal vector 2. So normal vector 2 means x1 is x is 1, y is also 1, so 1 into 1 is 1, so I will get 2 I cap, then j cap, and then k cap. This is what we have got, n1 vector and n2 vector. Now the concept is that these two are the normal vector and we have to find the angle between two surfaces. How do you find the angle between two surfaces? To find the angle between two surfaces, you find the angle between the tangent to the surface, and the angle between the tangent is also equal to the angle between the normal. So here, in spite of finding the angle between the tangent, I am going to find the angle between the normals. So we have vector n1, we have vector n2. So how to find the angle? We know that if we know a vector result, that dot product of n1 and n2 is defined as magnitude of n1 into magnitude of n2 into cos theta. Right, so we know this formula. So using this formula I am going to evaluate. Okay, so moving to the next page, because it will help us to get some space. So n1 dot n2, so basically if I want to find the angle, I can directly write the formula here, that cos theta is equal to, and here we can take the mod of this, because I want to find the acute angle. So n1 dot n2 and divided by magnitude of n1 into magnitude of n2. I hope you agree to this, and I take the mod of this, because if we get a negative value, then actually we take the modulus, because that will give us the acute angle. So here what is the n1 and n2? So n1 is where is n1? Minus 2j plus k. So let me write it, n1 dot n2. So n1 dot n2 will be, you know how to find the dot product. Let me write the vectors here so that you understand it easier. So here we have the vector n1 and n2. So dot product is calculated. There is I into I, so there is no I component here, so no need to write. Here j component is minus 2 and here minus 1, so I will get minus 2, and plus here the k component is 1 k coefficient, and k coefficient is 1, so I will get 1, right? And then magnitude, so magnitude what I will get, minus 2 square plus 1 square, so 4 plus 1. And for the second vector I will get how much, 2 square is 4, 1 square is 1, and 1 square is 1. So this is what we are getting. We are taking the mod of it, so I will get minus 1 by under root 5 and under root 6, that I can write as under root 13. So I can take the mod of it, which is equal to 1 by under root 30. So cos theta is this, so theta is equal to cos inverse 1 by under root 30. So this is the angle between the two surfaces. I hope you are finding the video interesting till now and have understood the concept. So let us move to the next idea, and that is known as directional derivative. So what is the meaning of directional derivative? The directional derivative of f, where of course f is a scalar valued function, in the direction of vector b cap, where v is the direction, and in that direction I am taking the unit vector. So it is given by del f, the gradient of the function, dot b cap, where b cap is the direction in which you want to find the directional derivative. What is the meaning of directional derivative? A directional derivative measures the rate at which a function changes in a particular direction at a given point. So if you have a function in 3 dimension or 2 dimension, and if you want to find that how the function will change if I move along the function in any particular given direction, so that can be calculated using the directional derivative. So let us understand through this problem that find the directional derivative of this function at the point 1 to 3 in the direction of this vector. So how do you solve it? As you can see that to find the directional derivative, first of all you have to find the gradient. Yes or no? You have to find del f. So let us first calculate the del f here. So can I write directly? Because by now you are smart enough to understand that how to calculate del f. So I have to take I cap del by del x of this. So del by del x of this will give me y square, and here I will get 4yz from the second term, and there is no x in the third term, so I close the bracket. Then I take j cap del by del y of this, so I will get 2xy and plus 4xz, and then I will close, and then I will take k cap, and with respect to z I will get 4xy from the second term and 2z from the third term. So this is what I am getting, but we have to find the directional derivative of this function at this point. So first let us calculate at point 1 comma 2 comma 3. So directional derivative at that point will be given by, can I write directly, 2 into 1 2 and into 2 4. So 4 sorry, I have to look at this. So y square, so y square is 4 plus 4yz, so 4 into 2 and into 3, let me write it, 4 into 2 into 3, that is I cap, plus 2xy, so 2 into 1 into 2 plus 4xz, so 4 into 1 into 3 j cap, and plus 4xy, so 4 into 1 into 2 and plus 2z, so that is 2 into 3 k cap. So this is equal to how much? 4 into 2, 8 into 3, 24 and 4, so 28 I cap, plus 4 and then 12, so 4 plus 12 is 16 j cap, and 8 plus 6, that is 14 k cap. Okay, so we have got 28 I cap, 16 j cap and 14 k cap. So I have got a del f, that is this, and we have to find the directional derivative in the direction of this vector. So what is the directional derivative? This is how usually it is represented, that directional derivative in the direction of b vector at the point that is 1 2 3. So it is defined as del f dot b cap. This is the definition. Let us look at this. Del f, so del f I already have calculated at the given point, and then we have to calculate the unit vector b cap. So what is unit vector b cap? The b vector is 3i plus 4j minus 5k, and I have to divide it by the magnitude of it. So magnitude of it will be what? 3 square 9, 4 square 16, and minus 5 square is 25. So I will get 3i plus 4j minus 5k, and it will be how much? It will be under root 50. So under root 50 can be written as 25 into 2, that is 5 under root 2. So this is the unit vector. So the directional derivative dB is equal to dB of the function f is equal to this vector. Which vector? That is 28i del f plus 16j plus 14k, that is the k cap, and dot 3i plus 4j and minus 5k cap divided by 5 under root 2. So if I calculate the dot product, 28 into 3, yes or no? So I can take 1 by 5 under root 2, and here I will get 28 into 3 plus 16 into 4, and then 14 into minus 5, so minus 14 into 5. If you evaluate this, you will get 78 by 5 under root 2. So you can verify this. So this is how we calculate the directional derivative. Let us quickly solve one more problem related to directional derivative. So in this question, they are asking that find the directional derivative of this function. If the function here is in two variable x and y, at point 2 comma 1 in the direction of a unit vector which makes an angle of pi by 3 with x-axis. So first of all, without any confusion, I can calculate del f. So del f here is, we have just two variables, so it is like I cap del by del x plus j cap del by del y, and here we have x square y cube plus xy. So how much is that? I cap del by del x of this will give me 3x, sorry, not 3x, x square will give me 2x, so it will give me 2x y cube and plus y, and then plus j cap, it will give me 3x square y square plus x. So at point 2 comma 1, at point 2 comma 1, what is del f, ladies and gentlemen? So if I can write directly, 2 into 2, 4 into 1 cube, so 4 plus 1, 5, yes or no? So I will get 5 I cap, and plus 3 into x square, so 4 into 3, 12, 12 into 1, 12, and 12 plus 2, 14. So I will get 14 j cap. So this is our del f. Now to find the directional derivative, we have to find the vector, that is b cap. So what is given in the problem? It is given that we have to find the directional derivative into the direction or in the direction of the unit vector which is making an angle of pi by 3. So this angle is pi by 3. So if I have to write the unit vector, so what will be the unit vector? I have to take the component of this in x direction and component of this in y direction. So basically the unit vector b cap will be how much? I hope you know how to take the projection. So if I have this unit vector b cap, right, so its projection in x direction will be cos pi by 3. Magnitude of b cap is 1, right? So it will be cos pi by 3 I cap and sin pi by 3 j cap. Did you understand this? Suppose I have a vector, let me explain again, whose magnitude is 1, right? So it means what? That its I component and j component will be what? If I call this vector, the vector is written like, b vector is written as magnitude of b into cos theta plus magnitude of b into sin theta. But magnitude of b is 1 because it is an unit vector. So that is just cos theta I cap plus sin theta j cap. So that is what I have written. Because it is making an angle of pi by 3, so it is cos pi by 3 I cap plus sin pi by 3 j cap. What is cos pi by 3? Cos pi by 3 is 1 by 2, so 1 by 2 I plus sin pi by 3 is root 3 by 2 j. So the directional derivative, if I can write directional derivative, let me write it dd, d for directional, d for derivative. So dd is equal to dot product of 5I cap plus 14j cap and dot half I plus under root 3 by 2j. So dot product 5 into 1 by 2, that is 5 by 2, 14 into under root 3, so plus 14 under root 3 by 2. So it is like 5 plus 14 into under root 3 by 2. So this is how we calculate the directional derivative. So to calculate the directional derivative, basically what you need the gradient and the unit vector in that direction. So now what I am going to discuss is very important, and if you have watched the video till now, watch the video till the very end, because this concept is very popular asked in many exams. So sometimes they ask the question that what is the maximum and minimum rate of change of a scalar field, and we have just understood that directional derivative gives us what? Directional derivative gives us the rate of change, the way the function changes in a particular direction. So if a function, I am calculating the rate of change of a function in a particular direction, I may also think about this, that in which direction the function will change maximum. There will be maximum rate of change of the function, right or not. So to understand that, let us look at the directional derivative concept. So we have defined the directional derivative of the function in the direction of unit vector b. So I can write db, dbf. So this is what it was defined as del f gradient dot b cap. This is how it was defined. Now you must have understood that if I have to find the dot product of two things, and the formula to calculate dot product is what? A dot b is what? We can write magnitude of a, magnitude of b, and then cos theta, right? So here also I can write magnitude of del f and magnitude of b cap into cos theta. But we know that this is a unit vector, so magnitude of a unit vector is 1, because that is why we are calling it unit vector. So what we get is del f into cos theta. But we know from our trigonometry class that cos theta lies between -1 and 1, right? And its minimum value cos theta is equal to -1 when theta is equal to pi, and cos theta is equal to 1 when theta is equal to 0. That we know. So if I have I'm just writing dbf, the directional derivative of the function f in the direction of the unit vector b. So its maximum value will be what? What is the maximum value? Max value of this is equal to, when this will be maximum, when cos theta will be maximum. So cos theta maximum can be 1, so its maximum value will be just the magnitude of del f. So the maximum value of this is equal to this, and it will happen in which direction? It is in the direction of theta is equal to 0. Now I have just written it deliberately to explain it to you. Suppose you have this surface, and if I talk about theta, what is the theta that I have talked about? It is the angle between what is del f? Del f gives you the direction of the normal vector, and suppose this is the vector b, right? So theta is the angle between the vector b and the vector del f. Yes or no? Now I am saying that this will be maximum when the theta will be equal to 0. This directional derivative will be maximum when theta is equal to 0. So when theta will be equal to 0, when the vector b and the vector del f will coincide, means they will be in the same direction. So the maximum value is magnitude of del f, and it is in the direction when theta is equal to 0. Means what? Means in the direction of del f. So the maximum rate of change of a function happens in the direction of which is normal to the surface. So if you are moving away from the normal to the in the direction of normal to the surface, the rate will change maximum. And when the rate will change minimum, so minimum value of this directional derivative will be when cos theta is minimum. Cos theta minimum is -1, so it will be minus of magnitude of del f, and it is in the direction opposite to del f, because when this theta will be 180 degree, when 180 degree means what, that suppose this is the direction of b, so this should be the direction of del f, means they are at 180 degree. In that case, this directional derivative will be minimum, because in that case it will be minus of del of f. So let me summarize it. What I expect you to understand, that what is directional derivative? Directional derivative gives you the rate of change of the function in a particular direction, and here I am talking about in the direction b. Point number 1. Point number 2, when it will be maximum, it will be maximum in the direction of del f. What is del f? Del f is the direction of the normal vector to the surface, right? And what is its maximum value? Its maximum value is just the magnitude of del f. What is the minimum value of directional derivative? It is a minus of magnitude of del f, and this minimum value is in the direction opposite to the direction of the gradient, that is del of f. So let's solve a few problems quickly, and then we will summarize the video. So the first question is that find the vector that gives the maximum rate of increase and find the maximum rate. So how to solve it? Find the vector that gives the direction of max. So we have to answer two things. First is direction of maximum rate. So direction of maximum rate is the direction of del f, we know, and then we have to find what is the maximum rate. So the maximum rate is the magnitude of del f. So we don't have to do anything. We have the function, so first we calculate del f. So what is del f? I can write directly I cap del by del x of this, so that will give me 6yz, plus j cap del by del y of this, that will give me 6xz, and plus k cap and del by del z of this, so that will give me 6xy, and at point -1 to 1. So at point -1 to 1, del f will be what? Y, so y is 2 into 1, 2, so it will be 12 I cap. Xz is -1, so it will be -6 j cap, and xy is -2, so it will be -12 k cap. Okay, so this is the del f in the direction of this. Now the first question is, what is the direction? So required direction. So required direction, or the direction in which it will be maximum, is equal to 12i minus 6j minus 12k. So this is the answer of find the vector, means we have calculated the vector that gives the direction of maximum rate of increase. So this vector gives the direction, because vector is a vector gives you a direction. So in this direction the function will change with the maximum rate. Now the second question is find the maximum rate. So maximum rate is what? Maximum rate is equal to magnitude of del f. So we just have to calculate the magnitude. So magnitude is how you calculate it. You take a square of I cap, so 12 square minus 6 square, and then again minus 12 square. So it is 144. Let me write 144 plus 36 and plus again 144. We have to take the square root of this, so that is equal to 288 and 12 300 324. So under root 324, it is equal to 18. So the maximum rate of increase is 18. We have a problem B also, in which I am asking the same question. So I want you that if you have watched the video till now, then comment in the comment section that what is the answer for the B part. Okay, let's solve this question now. Find the vector that gives the direction of minimum rate of change. Find the vector that gives the direction of minimum rate of increase. Minimum rate of increase. So means I have to find the vector minus del f. And what is the minimum rate? So minimum rate is, we have to find magnitude of minus del f. Okay, I hope you have understood this, that this is the minimum value and it is in the direction opposite to del f. So opposite to del f is what? If you take opposite of a vector, so what you get? You actually get means minus of del f. So if I ask you that what is the vector B which is opposite to vector B, so that is minus B. Okay, so let us solve this. So first we calculate del f. So del f is, I can write quickly now, so it is 2xi minus 2yj and plus 2z k cap, right? And at point 1 to 1, so at point 1 to 1, the del f will be equal to 2i minus 4j and plus 2k. So this is the point number 1. So the first question is that what is the direction? So I write it, direction of minimum rate of increase. Direction of minimum rate of increase is equal to minus of 2i cap minus 4j cap plus 2k cap. This is the direction. Okay, now the next question is, what is the minimum rate? So I calculate minimum rate is given by negative of the magnitude of del of f. So I take minus, and how do I calculate the magnitude of del of f? So del of f I already have calculated this. So a square of 2 square, that is 4, minus 4 square, so that is 16, and then 2 square, that is also 4. So minus 24 means minus 4 into 6, that is minus 2 under root 6. So the answer is, what is the minimum rate? Minimum rate is minus 2 under root 6. What is the direction of minimum rate? So minus of del f. So this is the answer. Okay, we have one more question here, so I want you to solve it and give me the answer in the comment section. So in this video we talked about lot of things. We talked about what is directional derivative, what is gradient, what is the meaning of gradient, how to find the tangent plane to the surface, how to find the angle between two surfaces. So we have done multiple kind of problems. In case if you have enjoyed the video, please like it, share with all your friends, and subscribe the channel as well. I'll be uploading videos related to other topic of vector calculus in the coming video. That's all for this. Thanks for watching and have a very great day.